So, hello dear students, welcome back. Hare Krishna. In this question, we will solve the 24th problem from the JAM 2025 paper. Here we have a very nice, interesting and nice question from law of large numbers and this entire large sample theory to be in general. So we have a sequence xk of IIT uniform -1 to 1 random variables. We define yn as this quantity root 3n summation xi by summation xi power 4, and the question asks about the convergence of the sequence yn in distribution as n tends to infinity. So the options can be either normal 0 1, normal 0 to 25. So basically, to be very broad, it either says about convergence to a normal or a degenerate at 0 random variable. So in order to solve any of these kind of questions, just recall what results you know. Like, to be very frank, there are many results in large sample theory, like the sample mean is going near the population mean. When you give a suitable scale, it goes to a normal distribution, right? So these kind of theorems are there, and also if you just take the sample average, it converges in a strong way or in probability to the mean, or also in some cases or under some assumptions it converges almost surely to the mean. Now how you can utilize this thing? So the very first step that you do is, or the roadmap here is very straightforward. It is CLT for summation xi with a mean 0 and some variance, that is precisely the variance of each xi. Next we have law of large number for this average, which converges to the expectation of this, and this two we have to combine using Slutsky's result. So that we will see. First, the very first thing is computing the moment. So expectation of x, as you can see, it's 0. Sorry for the typo here, it should be variance of x, that is expectation x square minus expectation square of x. The other part is 0, so this equals to 1 over 3, and similarly you can compute the fourth order moment is 1 over 5. So now from CLT you obtain that 1 over root n summation xi, this converges to normal 0 variance v of x, again sorry for the same typo, this converges to normal 0 comma 1 over 3, and this average converges to in probability to the mean, that is 1 over 5. So you can write like this, however it's not necessary, and to be very specific you can write it as you can take either, there are two ways. Either what you can do is you can write like this, or you can essentially write as 1 over square root n thing, and then there will be square root 3 into n times something. So this 1 over square root summation xi will be there, and this 1 over n summation xi power 4, this thing will also be over there. So this whole thing can be written like this. I hope it's clear. This 5 is coming from this expectation, okay, and this small op term, this is something that goes in probability to 0. So this 1 plus small op 1 goes in probability to 1. So here we are applying Slutsky's result, and this whole thing will go in distribution to 5 root 3 times normal 0 variance of x, that is 1 over 3. If you crack it inside, is 25 into 3 by 1 over 3, that is normal 0 25. So this is the result. Hence the answer should be option C. So this question was again straightforward, and actually there are similar kind of questions which were asked previously in the JAM paper. So in all of them, basically you need to manipulate slightly and get the form where we can apply the results from large sample theory. So that's it for this question. See you again in the next one. Hare Krishna.